Hi everyone. So in this video series I'm going to be going through the final exam review packet. So rather than just looking at the solutions where they're already written out, follow along with me as you're watching in your packet, and hopefully if you still had some lingering questions regarding how to do each of these problems, this video series would help. So if I did the whole thing at once, this video would be really long. So how I'm going to divide it up, I'm just going to go unit by unit. Okay? So we're going to go chronologically, but you may have noticed our review packet is a little bit out of order. So if you skip ahead to question 41, so the last page of the packet, we did a very brief unit on thermodynamics, or as it says here, energy and chemical change. Okay? But I'm just going to zoom in and write our full title there so we know what it is if that's what I'm referring to it as. Okay, but in our thermo unit, like I said, it was about a week long, and what we were looking at were a couple different things. We first talked about the difference between an endothermic and an exothermic reaction. So there are a couple things you could say for that. Certainly you should be able to look these definitions up on your own, but essentially an endothermic reaction, you have heat being added to the system, so the temperature is going up. Okay, in an exothermic reaction, heat is being lost from the system, or it's exiting. So it seems like the system is losing energy and the temperature would go down. Okay? Now, there are a bunch of other ways to define these as well. So on the next page, they had this graph there. Okay? So it asked you, based on what you wrote above for endothermic and exothermic, what would these graphs look like? Now you see these terms enthalpy over on the side, right? You see it there and there. Okay? Just think of enthalpy like heat. Okay, so if we're thinking of that like heat, the question is which one looks like it's gaining heat and which one looks like it's losing heat, right? Our exothermic reaction would look like it was losing heat. Our endothermic reaction would look like it's gaining heat. So, if we check out these graphs then, the one over here on the right, it starts at a certain energy level, and then all of a sudden by the end of the reaction, it has a way higher value, right? The products have a higher energy than the reactants. The only way that happens is if it's gaining energy right here, right? So if this one over here is the one that's gaining energy, we would say that this one on the right would be our endothermic reaction, which means the one on the left, since we start with a certain amount of energy, but by the end we have less, so the reactants have more energy than the products, we would say that this one is our exothermic reaction. Oops, that's not an E. There we go. Okay, so make sure you know the definitions of these two terms as well as sort of how to apply them here and there. If we get down to the actual math we did from this unit, there was only one formula, so if you look on your reference sheet, under the thermodynamics heading, you will see this equation. Alright, so let's remind ourselves what everything from that equation means. Alright, Q was heat, or in other words, energy. M we've seen a couple times, that's mass. C was what we would call the specific heat, but the full name is the specific heat capacity. The capacity is where the C comes from. And then our delta T, this is one variable. Delta T equals the change in temperature. So that's what the delta stands for, the change. So our change in temperature. Okay? Now if you're not sure how to calculate the change in temperature, this is the other formula you'll see under this heading. You'll see on your reference sheet, delta T equals TF minus TI. So the F and I are final and initial. Okay? So that was sort of a quick overview. If we now look at our actual problem, that's the formula we're going to be using. We just need to plug things in and see what we're missing. Alright? So, as we've seen with our gas laws unit, your first step should always be to write your equation. Right? So our first step, I'm going to write Q equals MC delta T. Now, it asks, what is the mass? So this is the one that we're solving for. That would be M, of a chunk of lead if 55,670 joules. Joules is an energy unit, so that's going to be E. All right. We then see 37 and 100, but we see degrees Celsius. So both of those are temperatures. All right. And then we see the specific heat. Don't get thrown because it says heat. Don't think energy there. The specific part, specific heat capacity, means this is our variable C. All right, so if I plug all those numbers in that we just wrote and solve for what we're missing, we'll be able to solve this thing. Okay? So let's do that. Our heat value would be this. Now if I go back, I think I actually wrote this as E, which was my mistake. Should have written this as Q. Okay. But there was our value. That was in joules. Okay. The mass is the one we don't know, so that's the one we're solving for. The specific heat it told us for lead was this, with this unit. And then our delta T, final minus initial. So if we look at the two temperatures, it says it goes from 37 to 100 degrees, meaning 100 degrees is the final temperature, minus the initial temperature, which was the 37. Okay? So if you don't like putting the units in there, you don't have to. The reason I put them in, though, is just so you can see that they do cancel out. All right? We would see that the Celsiuses would cancel there. The joules would cancel here. The only unit that didn't cancel out was grams, which makes sense because if we're solving for a mass, grams will be our unit of choice there. Okay? So now if I just simplify this, our mass, let's do it this way. I would divide both sides by the code of our variable. So I'm going to divide this side by 0.129 times 63, right, which is 100 minus 37 is 63, which means I need to do the same thing over here. All right, so we'd see that this would cancel, meaning our mass would be 55,670 divided by this product. And when we do all of that, please make sure you're trying the math yourself to make sure you do get the same answer when you solve this. We get about 6,850 grams of lead, so quite a large sample. Okay, but there's our final answer for our problem. So the big thing is make sure you know how to use this equation, Q equals MC delta T. If we were asked to figure out which type of reaction this is, endothermic or exothermic, there are a couple of things that give this away. When it says that heat is absorbed, that tells us something. It also says that the temperature increases from 37 to 100, so that tells us something. Both of those should tell you that this would be an endothermic process. Heat is being absorbed or gained by the system. Okay? So that's all of the problems from Unit 8, which was our thermodynamics unit. The next video will tackle Unit 9.